this lesson, we will learn about performing different operations such as adding, subtracting, multiplying, or dividing on radical expressions. When adding and subtracting, you have to have like terms. What that means is whatever's under the radical has to be exactly the same for them to be like terms. And then what you would do is add or subtract the numbers in front of the radical and keep the radical part the same. When you're multiplying or dividing, you can multiply both like terms and unlike terms. So let's go ahead and get started. When I look at number 1, 48, 18, and 27, those are not simplified, so let's go ahead and simplify first. I did a lesson on simplifying radicals before this one, so if you'd like to go back, you could review that. So 27 is the same thing as saying 9 times 3. 9 is the same thing as saying 3 times 3. Here is my set. Every pair goes outside, and I have a 3 left that has to stay inside. So I'm going to drop this 3 down times, I have here a set of 3, and then this 3 will go back in. I'm going to go ahead and bring the 2 down and break down 18. 18 is 9 times 2. I can break down my 9 into 3 times 3, and here's my set. So I have a 3 that will come out, but then I have this 2 here that didn't have a pair, so that's going to go back inside. Then I need to break down 48. I'll break it down right here. 48 is 8 times 6. I could do 12 times 4, really doesn't matter. 4 times 2 is 8. 2 times 2 is 4, and I need to break down the 6 into 2 times 3. So here's a set of 2's and another set of 2, and I have a 3 left. So I will have plus. When you have more than one set, you would multiply these together. So I have 2 times 2 is 4 times, I have this 3 left. So I actually don't need to do times. I need to put a radical here and put my 3 in there. Now I'm going to simplify this. 3 times 3 is 9, square root of 3, minus 2 times 3 is 6, square root of 2, plus 4 square root of 3. 9 square root of 3 and 4 square root of 3 would be like terms because under the radical, which is my square root, I have a 3 here, I have a 3. Those are the same thing. What I would do is now add what's in front. So I have 9 plus 4, that's 13, but the radical stays the same. It's kind of like if you have 2 oranges plus 3 oranges, that's 5 oranges. The oranges part does not change. And then I'm going to bring down the 6 square root of 2, and that's my final answer. These are not like terms because we have a 2 and a 3, so you cannot combine those. All right, let's do number 2. Okay, let's break these down. Square root of 100, that's a perfect square root. 10 times 10 is 100, so I don't need to do a tree because it's a perfect square root. However, if I did a tree, you would see that when you circle numbers, there'd be nothing left. So I have my 10. B to the third, I have 3 B's. I can get 1 pair out, 1 stays inside. So I have a B that will come out and a B will stay inside. Or I could have done long division on it where I'm dividing 2 because there's a 2 here for a square root. I'm dividing that by the exponent. You'll get, this is 1 B that comes out, 1 B that stays inside. It's just a different way of doing it. Plus square root of 81 is also a perfect square root, so that's 9. B to the third, we already broke it up to be B square root of B, minus square root of 9 is 3. Again, we already broke down B to the third to be B square root of B. Now, do I have like terms? For this one, you have 2 different types of like terms. So first, I have to have square root of B, square root of B, square root of B. That's good. But we also have variables outside. The variables have to be the same. Remember, when you're adding x's or y's, you have to have the same variable. So here I have 10b plus 9b minus 3b. So yes, I can combine this whole problem. So 10b plus 9b is 19b. 19 minus 3 is 16b. And then you keep your radical the same. That's my final answer. And for the last example, we're going to do a multiplication. Here we have distributive property, so I need to multiply this. When multiplying, multiply what's outside your radical together. So 7 times 4 is 28. Keep your radical. Multiply what's inside together. Square root of x times square root of x. I'm going to multiply x times x to get x squared minus distributed to this. So 9 does not have a radical, so it would get multiplied by what's outside. So 7 times negative 9 is a negative 63, but you have to keep that square root of x. Now I just need to simplify this. X squared, 2 divided by a 2 here would be 1. Or if I was to draw down two x's, that's a set right there. So I can take out an x. So here this is just 28x because I have nothing else to go back into my radical. And then for 63, I can break down 63. That is 9 times 7, and then I have 3 times 3. So the 3 will come out, the 7 will go inside. So this is minus a 3 that comes out. The 7 goes inside, but then I had an x here. I don't have enough x's to take out. I need at least 2 before I square root, so that x is going to stay inside.